All right, welcome back. We just saw that in the simple program where we were kind of reading some stuff from memory, sending that as a packet over the web from the US to Europe, that there was an enormous latency involved with that. All right, and what we asked ourselves is, can we invent a monad to make this visible, to make the fact that there's latency visible in the type? Just like we did with the try monad that made the fact that errors could happen explicit in the type. And the answer, fortunately, is yes. And the monad that we will use is called a future. So future of t is a monad that handles both exceptions and latency. All right, because still these computations can fail, but also they take time. So this monad really gives you both. Now let's look at how this type looks like. Well, here's the declaration of the trait future. And the single method, of course, there's a lot of helper methods there, but the most important method is the onComplete, which takes a callback that is a function of try of t to unit. Right? And what that means is this is this function that I talked about, this self-addressed envelope. So when you have a future, when you have a computation that can take a long time, what you do is you give it a callback, and that callback will, when that computation terminates, will call you back with the result. And that result can either be a regular value, a successful value, or an exception. All right? So that's where we see our good friend try of t come back. And if you look at the Scala definitions, again, the types might be a little bit more complicated, but this is the essence. And in particular, futures take this implicit execution context. You will see that is grayed out. For now, we will ignore that. In a couple of lessons from now, we will talk a little bit more about that. But for now, you just import execution context, punt implicit global, and you don't have to worry about that. Okay. Now here's a little bit of a kind of design question here, is once you have a function that takes a callback of that form, so a callback that has type try of t to unit, it means that that function internally probably will do pattern matching, or it will use some of the combinators, the higher order functions defined on try, but in many cases you will do a pattern match to check whether your computation succeeded, then you do one thing, or when your computation failed, and then you do another thing. So this design of future is not the only possible design. For example, what we can do is we can take the functions there on the right-hand side of that pattern match, the onNext and onError, and pass those separately into the onComplete callback. Or what we can do is we can say, oh, there's two functions there. Let's put them in a type themselves and pass that. So let's look at that, how that would look like, okay, where we only focus on the essence. So the first one here would be that onComplete would take two callbacks, one when the function successfully completes, and one when it fails. If you're a JavaScript programmer, you will see that JavaScript often uses this model. So a lot of JavaScript-based APIs that deal with asynchrony will take two callbacks. One success continuation, so sometimes these callbacks are also called continuations. So what you will see is that they will take a success continuation, which is a function from t to unit, and a failure continuation, which is the one that takes the exception and also returns unit. But of course, what we can also do is we can package up these two functions into its own type and then pass an instance of that type. So that would be the more OO approach to this. And I'm showing you these alternatives because many languages, many libraries all have their approaches to dealing with futures in one way or another, and it's good kind of to see that they're kind of all the same. Really, the essence is that you provide a callback that will be invoked once the computation that has a high latency has terminated. All right, so let's, given this type future of t, let's adapt our types to show that reading from memory, and especially sending packets from the US to Europe, can take a long time. So now the signatures read from memory gets a future of array of bytes, meaning this will be a computation that takes a long time, so we have to provide a callback to that. And then send to Europe is the same thing. It returns a future of array of bytes. But future, of course, has a lot of higher order functions defined on it, because otherwise we would get stuck in writing ugly code like this, or even kind of stuck at all, like here. We first read from memory, so what we get back is a future of array of bytes. What can we do with a future? Well, we can call onComplete, where we have to give it a callback. But now the thing is that what happens when we get a failure? Because the onComplete must, what do we do there? So this kind of is a little bit unfortunate, this code. So what do we do? Well, what we can do here is we can kind of, refactor it a little bit, and we say when we are on complete, we call the packet sent to Europe. When we do fail, yeah, it's still not, you see, it's like pattern matching and lots of nesting. So what are we going to do now? What is our friend? What's coming to the rescue? That's flatmap. All right, so we have now a monad, a type constructor, that allows us to express the fact that computations take time and that they can fail. So let's use this type constructor future to make our types more precise. So here was our socket class, read from memory, sent to Europe, and now instead of directly returning an array of bytes, read from memory will return a future of array of bytes. And now you can look at this type and you can see, this computation will take a long time, so it will return a future. And what do I do with this future? I give it a callback that will be called once my future completes, either with an exception or with a regular value. And similarly, for send a packet from the US to Europe, which took a really long time, so there also the type becomes future of array of bytes. Now, just like with try of t, the code becomes quite messy. Because we can first, calling read from memory is easy, because we get a future of array of bytes. But now, what do? We now have to kind of do packet onComplete. But onComplete took a callback, that took a try of t to unit. But what we want is we want to have a confirmation that is a future of array of bytes. So, this is kind of problematic, right? We cannot write it like this, because the right-hand side here, it will be of type unit, whereas what we want is a future of array of bytes. So there we see that the compiler is complaining. There's the red squigglies. You never want to see those red squigglies in your code. But what can we do? So let's try to refactor this code a little bit such that we can return a future of array of bytes. So let's, again, we read from memory. And then we say when the packet completes, we give it a callback. We get the confirmation. But now this confirmation of the right type is nested inside this complete. So this is the problem with callbacks. Your code gets all tangled inside out. So yeah, that's not very handy. But let's push this to the next lecture when we're going to talk about the higher order functions on future. Let's just look like a little bit more about how we can construct futures and so on. So here's how you construct a future. A future takes a body, a computation, and here you see this by name function, you know, arrow t, and it takes an implicit execution context, and then it returns a future. And again, don't worry about the execution context because we are importing the implicit global execution context. But what this constructor does is it starts an asynchronous computation and immediately returns a future that you can register a callback with when the future completes. Now what is important to notice is that you can, of course, supply several callbacks to that future. And the behavior of a future is that this callback is called at most once, because the computation might never terminate, but when it terminates, it's called exactly once with the value. All right? And if the computation has already terminated and you're adding a new callback, that callback will be called immediately. So here's a small example. We are creating 3 email messages, and then we're reading from memory and future array of bytes, and this is defined as follows. We kind of take the email from the queue, we serialize it, and then we return the binary message. So this is the read from memory. But now notice that whenever I kind of put a callback to this read from memory, the code in that body will be executed only once. So it's not that when you register 2 callbacks that 2 emails will be read. All right? So that's important. So here's a body with side effects, but for every callback, the side effect will happen only once. So this is a very important thing with a future. All right. Thank you so much, and see you in the next lecture when we're going to talk about higher order functions on futures.